Hello everyone, this is again Teacher Jenny guiding you on the second module for quarter 4 of Mathematics 8 with the topic Proving Inequalities in Triangles. Taken from the module titled Proving Inequalities in Triangles by Melody B. Witwag. At the end of this video, you are expected to prove inequalities in a triangle. But before that, let us have first a recap of what we have discussed on the previous lesson. We have here this figure. Note that from our previous lesson, we had stated that the measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. So based on the figure, we have measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 2. And that is based on the exterior angle theorem. Again, it states that the measure of an exterior angle is equal to the sum of its remote interior angles. Now, considering the same figure, we can also have these two inequality statements. We have the measure of angle 1 is greater than the measure of angle 3. And the measure of angle 1 is greater than the measure of angle 2. Now, if we look at the relationship of those three angles, angle 1 is an exterior angle, and angles 3 and 2 are the remote interior angles of angle 1. So based on these two inequalities, it is very evident that the measure of an exterior angle is greater than the measure of any of its remote interior angles. And that is based on the exterior angle inequality theorem. Next, we have this one. We have triangle JEN. Segment JE has one tick mark and segment JN has two tick marks. That means those two segments are not congruent. And the measure of segment JN is greater than the measure of segment JE. Now, based on the given, we can say that the measure of angle E is greater than the measure of angle N. Angle E is the opposite angle of segment JN, and angle N is the opposite angle of segment JE. So since segment JN is longer than segment JE, then it follows that the opposite angle of segment JE is greater than the opposite angle of segment JN. So we have measure of angle E is greater than the measure of angle N. That is by the inequality theorem 1 or the side angle inequality theorem. Next, we have this one. So in here, angle U is larger than angle T. So it follows that the opposite side of angle U, which is segment QT, is greater than the opposite side of angle T, which is segment QU, or the measure of segment QT is greater than the measure of segment QU. And that is based on inequality theorem 2 or the angle side inequality theorem. Next, considering the lengths of three segments, let us determine if those three segments can form a triangle or not. First, we have the lengths 2, 4, and 6 units. Can we form a triangle using the given lengths of segments? Very good, we cannot. Because if we add the lengths of those two smaller segments, that's 2 and 4, it's equal to 6. And 6 is equal to 6, which is the measure of the largest segment, and not greater than 6. Therefore, we cannot. How about this one? 3, 7, and 9 units. Can we form a triangle using the given lengths of sides? You're right, we can, because if you pair 3 and 7, that gives us 10, and that is greater than the third side, which is 9. If we pair 7 and 9, that's 16, and again, it's greater than the third side, which is 3. And then if we add 3 and 9, that gives us 12, which is greater than the third side that measures 7 units. How about three sides with lengths 8, 2, and 5 respectively? You're right, we cannot, because if we add 2 and 5, that is 7. And 7 is less than 8. So we have found a pair of measures of segments which is less than the third side. So that is how to determine if the given lengths of segments can form a triangle or not. And that is based on the inequality theorem 3, or S1 plus S2 should be greater than S3. Or the sum of any two segments of a triangle should be greater than the third side. So if you can find at least one pair of measures of segments which is not greater than the third side, then that means we cannot form a triangle using the given lengths of segments. Next, we have this one. So we have two triangles here. Two sides are congruent. Considering the included angle in its opposite side, and without changing the position of the first triangle, then this figure shows that when we increase the included angle, then the opposite side also increases. So if the included angle of one triangle is larger than the included angle of the other triangle, then its opposite side is also longer than the opposite side of the other triangle. Because as you can see here, as the measure of the included angle increases or decreases, the opposite side also increases or decreases. And that is based on the hinge theorem. And for the converse of the hinge theorem, given two triangles with two congruent sides, if the third side of one triangle is longer than the third side of the other triangle, then it follows that the included angle of the first triangle is also larger than the opposite angle of the second triangle. So that is the hinge theorem and its converse. Now let us proceed with proving inequalities in triangles. Given here are triangle RDA is isosceles with base segment RA. Segment ED is in the interior of angle RDA, where angle 1 is greater than angle 2. Prove that segment RE is greater than segment EA. So in proving inequalities in triangles, we will be using the two-column proof. So we have here the statement and the reason. For our first statement, of course, we have from the given that triangle RDA is isosceles. That means, then based on the definition of isosceles triangle, we can say that segment RD is congruent to segment AD. Because when we say isosceles triangle, two sides are congruent. So if you're going to look at the figure, there are two triangles formed. There are two smaller triangles formed. Those are triangle RED and triangle DAE. Based on those two triangles, we have a common side, and that is segment ED. So we can say that segment ED is congruent to segment ED by reflexive property of equality or congruence. Then next we have the second given, which is angle 1 is greater than angle 2. So this is segment ED is congruent to segment ED. Then we have angle 1 is greater than angle 2. So we have here two triangles with two pairs of sides which are congruent and the included angle which are not congruent. Now, how can we prove that segment RE is greater than segment EA? So if you're going to observe, segment RE and segment EA are the opposite sides of angle 1 and angle 2 respectively. So that means that statement can be proven by the hinge theorem. Another example, given segment OR bisects angle WOK. R is between W and K. Prove that segment W is greater than segment WR. So first, we have to consider the given, which is segment OR bisects angle WOK. Then, if you can still remember the definition of angle bisector, if segment OR bisects angle WOK, then it divides the angle into two congruent parts. So we now have the measure of angle 4 is equal to the measure of angle 2. Then for our third statement, we have the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Now, if you're going to look at those three angles, we have this 1, 2, and 3. How can we prove that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3? You're right, it is based on the exterior angle theorem. Now, based on statement number 3, we can now say that the measure of angle 1 is greater than the measure of angle 2. And that is based on the fact that the whole is greater than its parts. For our next statement and reason, we have to use substitution property of inequality. So, since measure of angle 1 is greater than the measure of angle 2, but the measure of angle 2 is equal to the measure of angle 4, then we can now say that the measure of angle 1 is greater than the measure of angle 4. So now we can prove that segment WO is greater than segment WR. And that is based on what inequality theorem? Very good. It's the angle side inequality theorem. Next example, we have here on the figure, segment LV is congruent to segment EI and segment LI is less than segment EV. Prove that angle 1 is less than angle 2. So again, for our proof, our first statement, of course, comes from the given. And those are segment LV is congruent to segment EI and segment LI is less than segment EV. Then, based on the given figure, we can see that there are two triangles formed. And considering those two triangles, which are triangle LIV and triangle VIE, there is a common side, and that is segment IV. So we have our second statement, segment IV is congruent to segment IV. That is, of course, based on the reflexive property of equality or congruence. So based on our previous statements, we have this one. IB is congruent to segment IB. And then segment LI is less than segment EB. Now look at the two triangles. So we can now see that the two triangles have two pairs of congruent segments. But the third side of angle LIV, and that is segment LI, is less than the third side of triangle VIE, which is segment VE. So with that, we can now say that angle 1 is less than angle 2 by what inequality theorem? Of course, we have the converse of hinge theorem. Next example. Given segment ST is congruent to segment TY, prove that segment SD is greater than segment YD. We have here a hint to give you a clearer picture of what we need in proving the given statement. We may separate the figures to better visualize the parts being considered. So we have here triangle TDS and triangle DTY. This is the larger angle and this is the smaller angle. So for our first statement, of course, we have the statement from the given, that is segment ST is congruent to segment TY. We have these two sides. Next, we have segment TD is congruent to segment TD. That is based on the reflexive property of equality. Then for our third statement, we have the measure of angle STD is equal to the measure of angle 1 plus the measure of angle 2. So this angle is equal to the sum of the measures of angle 1 and angle 2. That is based on angle addition postulate. The whole is equal to the sum of its parts. For our fourth statement, we have measure of angle STD is greater than the measure of angle 1. We have the statement the whole is greater than its parts. So now we can say that segment SD is greater than segment YD. Since we have two triangles, two sides are congruent, and the included angle of one triangle is greater than the included angle of another triangle, then the opposite side of the first triangle is longer than the third side of the other triangle. And that is based on the hinge theorem. Let's now have our last example. Given point C is the midpoint of segment FS. Measure of angle 1 is equal to the measure of angle 2, and the measure of angle 3 is greater than the measure of angle 4. Prove that segment OF is greater than segment US. So for our first statement, we have C is the midpoint of segment FS, that is from the given. And then based on the definition of midpoint, we have segment FC is congruent to segment CS because point C divides segment FS into two congruent parts. So this segment is congruent to this segment. Next, measure of angle 1 is equal to the measure of angle 2. So this angle is congruent to this angle. That is again from the given. Then next, we have if the measure of angle 1 is equal to the measure of angle 2, then segment OC is congruent to segment CU. And that is based on the converse of isosceles triangle theorem, which states that if two angles of a triangle are congruent, then the sides opposite those two angles are also congruent. Then for our fifth statement, we have the measure of angle 3 is greater than the measure of angle 4. So this angle is greater than the measure of this angle. That is again from the given. Now we can say that segment OF is greater than segment US. And again, that is based on the hinge theorem. So that is how to prove inequalities in triangles. If you have questions, don't hesitate to type them on the comment section. But before we end this video, remember that there is no definite way in proving inequalities in triangles. But in order for you to prove, you have to master the different definitions, theorems, properties, postulates, axioms, and other needed statements in proving triangle inequalities. So that's all. Thank you for watching. Goodbye.